Hi guys, it's Ms. Robinson, and today we're going to be discussing Earth's water resources. So we're going to be focusing on the freshwater resources. So make sure you pay attention and listen because some of the facts that I'm going to be sharing with you are not necessarily on the screen, um, but you're going to be probably need to write it down. Okay. All right, so the distribution. So, what is the distribution of water on Earth? It is very important, obviously, to know how much water covers our planet. So, the water covers 71% of the Earth's surface. Um, so, the other 29 is going to be on land. So, that 71%, 97% of that water is going to be salt water, which is our oceans, and only 3% of the fresh water, which is 2.2%, is frozen, and the other zero point 0.6 is flowing. And any remaining percentage is going to be locked or trapped underground or something or in the atmosphere. So when you think about how much water is fresh on the entire planet and is easily accessible, zero point 0.6 right here is a very small percentage if you think about that. Okay. All right. So where could we find more water trapped in ice? So we have to think about the different areas that we look at. Okay. So a glacier. They're large mass of ice that move slowly over land. So whenever you think of a glacier, we have to think of all the icy area glaciers. They're huge, big slabs of ice, just that just moves over the land. So this huge piece of ice just travels over the land. So this is one area where we would find our trapped ice. So you can see right here, this is the water, or I can do that blue. Here's the water, and then you have your trapped ice, and it's just moving slowly along. Okay. The second area is an iceberg, and it's important to know when we look at this that the iceberg is a small portion on top. As you can see, this small here, and this large portion here at the bottom is under the water. So, but again, this is where we find ice that's trapped. It's not something flowing or usable for us to drink, but it is fresh water that is trapped. Okay. Also, we do have something called permanent snow, and it means exactly what it is. It's snow that's permanent. So, if you're climbing up the mountain, we would expect that all of the snow here would be here every single day. So, this will be here every single day. It is permanent. These are all areas of fresh water being trapped, not something very usable for us. So, what is one thing that can be as hard as rock, fill a glass, or float inside of a cloud? If you guessed water, you are correct. I know that we talked about the different states of matter. That's the fact that water is so unique that it can be found in three different states. We have solid, liquid, and then our gas. Remember that triangle that we did during the states of matter, and it can be all at the same. Water can be in any state. Okay, so our freshwater sources here on Earth. So let's take a look at the freshwater sources. So the difference between a watershed and a river basin. Um, so both terms describe land that drains into a river, stream, or lake. So it drains into a river, stream, or a lake. Okay. So think of the water that comes tumbling down and it hits the ground, and then the water is going to be moving towards something, either towards a river, stream, or a lake. It's moving somewhere. Okay. So that's a watershed or a river basin. The difference between the two, a watershed is going to refer to small. So a watershed is going to be small. And where a river basin is going to be large. So I'll change the color. And that's going to be larger. Okay, there are 17 river basins here in North Carolina, and we'll expand on this later. Okay. All right, so a river basin. So we can see here all throughout the basins, they're leading into one main stream. So this is the main here, main water area, excuse me. So the basin is drawing towards a central area that's that's flowing towards an even greater. So you can see here it's flowing and is leading to something greater. Think about Finding Nemo when it says all things are leading. All things drain lead to the ocean kind of thing. So think of it as the same thing, like little creeks, streams, and all that eventually are heading towards something. So a watershed, same thing, but smaller scale compared to the river basin. As you can see here, you have the smaller color. Let's do this. So everything smaller is leading to something bigger. Okay. All right, so how are river basins and watersheds connected? Large river basins are made up of many interconnected watersheds. So think of your watersheds as your little creeks and streams, and they all connect together towards this larger river basin. The water is flowing towards its lowest point. That's where the bodies of water are headed towards. All right, so for example, the Cape Fear River is an example of a river basin. It looks like a little highways um, of water, and you can see here that the Cape Fear River will eventually be leading towards the ocean. If you look back up here, you can imagine there's a lot of areas of water that are draining towards a larger place. Okay, so you have here flowing throughout the city, and then flowing to a larger basin going towards the Atlantic Ocean. All right, so and here's another picture of the Cape Fear River. You can see everything's leading towards the ocean, the Atlantic Ocean. If you've ever been to the coast of North Carolina. So, what is the difference between a lake and a pond? All right, so the difference pretty much is size. So Hyco Lake and Houston Pond, that's at Cornell University. So you have to know the name of the pond. You don't have to know the name of the pond. You just need to know the difference. So you can see the difference here of the pond. The pond, you can see the size is a little smaller compared to Hyco Lake, where it is much larger. With the pond, it has several pod grasses. You can see right here, and it's much shallower. A lake can be very, very deep. And if I'm floating in a pond, I can see the bottom. You can see the bottom of a lake you can't see the bottom of the lake if you're floating. Okay. So, what are some examples of fresh surface water? We have a stream. Streams are very small rivers. Large creek is very short, shallow. It's a battling brook. Okay. The Eno River here in North Carolina, the rivers are much larger in size if you want to look at it going across. It's a little deeper. Swamp is a type of wetland that is dominated by trees. A wetland is where a water table is at or above the land during the year to support plant growth. It's not going to be crazy deep. Um, A bog is not deep. If you've seen the ocean spray commercial with the cranberry guys and they're standing in there with the cranberries, this is where you're going to have enough water to continuously support the plant growth. A marsh is dominated by grasses. If you've ever been to Charleston or Savannah, very tall grasses. They're shallow, enough water to support water levels as they rise and fall. So, what does it mean by turnover? When water gets colder, it sinks in its cycle. Okay, so rising and sinking of cold and warm water layers in a lake. So we have thermoclines and lake turnover. Is not It doesn't turn over in the winter, and summer is mixing of water. So you can see here in the spring it's starting to mix. In the summer the oxygen level is high. In the winter time it's high, and then the fall is turning over. It's changing in that season. It's mixing that water. Okay. All right, so the final term we're going to be discussing is eutrophication, and it is all you need to know is that there is an increase of nutrients that eventually leads to a formation of a field. What that means is that water is getting pumped full of nutrients like fertilizers. If I put a lot of nutrients in a pond, it's going to cause the plants to grow and grow and continue to grow. You'll see this scumminess in the water right here. All this scumminess in the water it's going to start to disappear. Okay, we sort of speed up eutrophication during because we add a lot of stuff into the water that is nutrients that causes plants to grow. As you can see, the cities we build, the sewage going into the water, the nitrogen compounds from the cars and the factories, discharge of the treated sewage, runoff, natural runoff, and runoff from the streets, lawns, and construction. All right. If you have any questions, please let me know. Make sure you took thorough notes. You can replay it, rewind it, pause, and stop. Remember to take your video notes quiz on Freshwater.